after decades of earnest public information campaigns, Americans are finally recycling. Airports, malls, schools, and office buildings all across the country have bins for plastic bottles, aluminum cans, and newspapers. But now much of that recycling is unprofitable and ending up in landfills. Smart bins is a solution to this problem and aims to be an efficient and cost-effective way to make recycling profitable and take care of our earth for many years to come. Waste management is currently a two-factor problem in the United States. First, 49% of respondents do not know whether to compost, recycle, or trash their waste. Second, recyclable material is no longer profitable. In 2018, China reduced its contamination rate of recyclable material to 0.5%. Because of this, US recycling practices couldn't maintain this rate and could no longer sell waste to China. As a result, recycling facilities have shut down and about 50% of our waste goes to landfills. Here you can see the waste chain in the United States. We believe by focusing on the bin collection part of the larger waste chain, we can begin to solve this issue.
Our solution offers both a hardware and a software component. On the hardware side, we are essentially mounting a scanner on top of a campus bin. The scanner is able to detect what category a piece of trash is from a given picture. The scanner itself will be targeting both the general public and campuses and offices. People who previously didn't know where the trash was supposed to go will now have an easy way to figure out exactly where to deposit their trash. Furthermore, universities and campuses will see our product as a way to promote their sustainability and eco-friendly goals. On the other hand, we also have implemented an information system that essentially provides an analytics platform to recycling facilities and trash collectors. Through the scanner, we have access to the data inside each bin that a recycling facility owns, and we are then presenting this data in an online platform that these companies can use to optimize all of their operations.
So the hardware component combines computer vision with 5G technology to develop smart bins that detect and classify trash into the right compartment. So how does it work? So basically the user scans the trash and the image is transferred to a server in the cloud, where a computer vision algorithm classifies it and sends back a response to the smart bin. Based on that response, the bin will turn on a LED light indicating the correct bin. At the beginning, we thought of using a robotic system to separate trash for you, but we realized that it would increase a lot the cost of the product and people could still use their hands to throw the trash. They just needed to be guided by the system. That's why we decided to pivot to LED lights. We believe there are three top requirements for a product to succeed. The first is accuracy, so we can't decrease contamination rate if we don't classify trash correctly. Our prototype, for example, has 90% of accuracy on the test set. Second, speed. Students on campus are usually late to class and would not use our product if they had to wait a long time for a response from the bin. So ideally, we should have less than 1 second between scanning and turning on the LED. And finally, the product should be intuitive and easy to use. So here we built a prototype with Raspberry Pi for a proof of concept. So the red means metal glass, so the red light should be turned on. And then we scan the paper, so yellow should be turned on. And finally, we scan a plastic object, so the green light should be on. Why do we need 5G? First, we need the low latency. As I said before, we need a fast response from the system, ideally less than 1 second. And second, we need the greater bandwidth. We'll probably have multiple smart bins powered by 5G close to each other on campus, and all of them will be uploading images to the server. Third, there may be limited Wi-Fi connection coverage outside of campuses, so if we want to expand our product for other environments. And finally, it will be very expensive to buy a powerful processor to run the algorithm internally.
Here's a little bit more detail about the information system. So essentially, each recycling facility is going to be owning certain bins, and they will have access to the data inside each of these bins, which will be stored in a universal database. So for example, some of the data that we are providing is the number of scanned items, the number of unscanned items, the last emptied time of the bin, and the location of the bin. This information is then displayed in a dashboard that on a homepage that a recycling facility can log in and then view. Furthermore, they can also use this data to run a variety of services that will optimize many of their operations, such as routing and location tracking.
We developed a real-time analytics concept that allows waste management operators to get a holistic view of all the regions that they're servicing. In addition, they can look at the details of each individual bin. So let's get logged in and I'll show you around. So right when you log in, you'll be faced with a map of the region or the area that you're servicing. And for us, that's the Bay Area. And here you can see that each icon is color-coded so that if it's red, that means it needs servicing really soon. And if it's green, then you can probably leave it alone for now. And if also you can hover over each one of these icons to see a quick status view of each individual region, like so. So now, if you click into Oakland, you can see the individual regions bins, and each of these icons represent one bin. One feature that we're really excited to show you is the routing feature. So if you click on the routing button, it'll present to you optimized routes of which bins you should pick up right now because they're full. So in the current system that most cities and waste management systems use, they have trucks that travel on predefined routes, and they stop at every single bin, which is really inefficient. With smart routing, we can eliminate this inefficiency and stop at bins that are only full.
Let me now walk you through a current use case that we have. Now that from the standpoint of a physical bin, there are essentially two options. First, a user can scan the bin to figure out exactly where to put their trash. And second, a trash collector who has just emptied the bin can press a button on the scanner to signal to the system that the bin has been emptied. The data from the scanner is then sent to the information system, where a recycling facility can log in and track their bin's metrics. They can then use this information for a multitude of optimizations like Gary mentioned previously. These optimizations will help save both time and money.
So what we see in not only California, but throughout America is that the amount of trash that each person is generating has really gone up. Here's some data that we found from CaliforniaRecycle.gov, which basically shows from 2014 to 2016 on the graph on the left side, you can see that the per resident disposal went up from almost 45 million tons to 50 million tons. And on the right hand, you can actually see where the recycling rates by the years 2014 through 2016 actually fell from about 50% to 44%, whereas the statewide recycling goal is actually at a 75%. So what we see is with current trends, they simply cannot hit this. And our solution would really help them hit this goal, which would not only help the environment, but also the world as a whole.